Right. In today's video of MathSpace, I'll be covering the last part of matrix and also the most important one, which is matrix applications in AI model. Right. So in general, the only function that we use matrix in constructing AI models is to store data. And today I'll be giving you two examples. So for examples in neural networks, which are deep learning models, right? So you see there are different combinations of different layers in the model, right? So these are called nodes, and each of these nodes contain a number, and the value of the nodes of this layer depends on all the nodes of the before layer. So, theoretically, we can construct the value of each nodes by, just calculating from each of the before layer. But because in AI models, efficiency and computational power is really important, so what we do is that we store the value of each layer in a vector. So x layer 1, which is this one, contains all the value of the nodes, which is x1 to xn. Then you have x layer 2, which is equal to y1 to ym. Right, so practically these matrix right here stores the value of each layer. And the reason we store is, first of all, more efficiency, and secondly, in a lot of deep learning models, we often, instead of just having different independent variables being computed, then we compute it using matrix operation, which, for example, if you want to calculate the x of layer 2, instead of just calculating what x1, y1 is, y2 is, and then ym, then what we're gonna do is we are gonna just pick the whole of layer 1, then we multiply it by the weight of the layer 1 plus the bias of layer 1 before putting all of them in the activation function. Right, so that is practically how we computed the whole value of the vector of x layer 2, and it saves a lot of time instead of just computing each of the independent variable. And secondly, in processing images, right, so because for example you have an image, so you often heard of the word like it is 256 by 256 pixels, right? So you can imagine that there's small bits of pixels, that each pixels right here represent a value a, and a is in the range of 0 and 255 that represent the value of the color. So you can imagine 0 as completely white and 255 as completely black. And so an image is a matrix. Which example is A11 to A1556 to A556-1 and A556-556. So practically an images is just a representation of a matrix. And what we say when we process the images is that we take out the value of each of the elements inside the matrix and we do operations within the matrix. And so as you can see,